Hello everyone, this is Coach Jordan from Milford Robotics, and today we're going to talk a little bit about Spike Prime versus Ev3 for FLL. So just a little bit about us. We are a robotics organization from Milford, Connecticut. We have a couple FLL teams and an FRC team, and we're trying to put together content to help the rest of the teams out there, and particularly with the problem that we're having, which is whether or not we should use Spike Prime, and learning how to use the new Spike Prime and the new Scratch. And so hopefully this is something that's helpful to you. So I just want to be clear that when we're presenting today, when we're really talking about is FLL, we're really interested in FLL, making sure that Spike is going to be useful for FLL, so this is really couched in that. We're not talking about Spike Prime outside of FLL. Alright, so the first thing I'm going to do is I'm just going to talk about some other great things about Spike Prime and 10 reasons you might want to choose Spike Prime over Ev3 for FLL. And then I'm going to just caveat this first, that I am not going to consider the portions of Spike Prime or the portions of Ev3 that are interchangeable. So just switching to the main camera here for a second, any of the pieces here that I could use on either. So for example, these great wheels, the new plates, the new gears, the new biscuits. So these great new pieces are called biscuits. Really wonderful. Any of that stuff is interchangeable. Any of the parts that you could use for Technic could be used on this. Any of the Spike Prime parts that are not wired into the Spike Prime operating system, you can use on an Ev3 robot. So we wouldn't consider them. While we're here, I just want to point out the really, really wonderful new wheels that come with Spike Prime, and you can absolutely see these being used on an Ev3 robot next year. In fact, I would almost guarantee that you'll see some of that. So we won't be considering the parts that are interchangeable when we're talking about positives and negatives, because they can be used by either. And I think that's a really important point, just to getting started, that there's benefits here for both Ev3 and Spike Prime users. Alright, so one of the big reasons that Spike Prime is so wonderful is just the sheer size of things. Much smaller, more compact, and easier to use, and that's true of the hub, which we'll look at in a second, but it's also true of the sensors and the motors as well. And that's just a really good benefit for FLL, because it means that you can build smaller robots and have more room on your robot to do other things. It means you can fit into smaller places and position your hub in different ways, so that allows you to do things on top of your robots that maybe you couldn't do with the Ev3. So here I'm just gonna, this is a brick from Ev3, comparing it to Spike Prime next to each other. You can see that it's approximately 3, maybe 4 spots shorter, probably more like 4. And then also you can look at it width-wise, it's just slightly, maybe 1 or 2 bricks thinner. One of the biggest reasons though is that just height-wise, the Ev3 brick has things that stick up on top, the screen, and things that stick out on the bottom. In this case I have the battery in, and that just makes it wider, comparing that to the Spike Prime brick, which is exactly 4. I think this one is 4, 5, and maybe 6 if you include the parts that are raised that it would fit into. So there's a huge benefit there. And then the other thing we could talk about here is the sensors. Hopefully I can show these to you. They're almost exactly the same size in many cases, except that the connectors for the Ev3 sensors stick out. So the part that you connect is here. There's no way to connect to the actual sensor itself. And so you lose quite a lot of space in order to make that work, whereas on the Spike Prime sensors, you've got at the corners connectors drilled directly onto the sensor itself. And that same thing is true of the motors. You've got the medium motors and the large motors. These are the large motors here. You can see that they are, I would say, maybe 10, maybe 9 Lego bricks long and only 3 wide. Although they do stick out. I think it's 4 wide for the large motor, and even smaller for the medium motor. Whereas if you've, here I'll just bring in the Ev3 robot real quick for a second. if you talk about the large motors or the Ev3 brick in the context of Ev3 and for competitions, it's just so much larger and taking up so much more space. You can see our brick here is taking up almost half of this top surface area of our robot, and even though this robot is pretty compact, so it really is. And then you can see also here on the side here, that's a approximately 6 bricks tall, making this stick up pretty high in comparison to the height of a Spike Prime robot. That makes a huge difference in flexibility for you, weight, etc. So that's a pretty big one, is the height. So let's come on back to our presentation. So smaller is the first one. Better sensors, the touch sensor in particular. The sensor, when you press the touch sensor, I can bring this back. You can see that when I press, there's force feedback there. On the Ev3 touch sensor, you have 2 values, on or off. Here you get a level of pressure, and it increases as you push down. So there's a lot more that you can do with that, and you can sense how much you hit something, how fast you hit something. Some more possibilities there, so that's much better. All right. Speed's a big one. There's a faster boot up, faster shutdown, faster connectivity. Just in general, it's a lot faster. In fact, it's so much faster. Let's just even see that. So I'm just gonna turn off the Spike Prime. All right, it's off. Boom. And then I'm going to turn it on again. And it's on. If you ever turned on or off an Ev3 brick, you know that it's probably 20 times longer than that to turn it on or off. It takes 60 seconds or more to turn on or off your brick each. 60 seconds to turn it off, 60 seconds to turn it on sometimes. So that's a huge difference, and especially when it comes to repeating things. Or doing experiments, or trying to run things over and over again, or having to reset. That's a huge difference. The same thing is true of connecting your Bluetooth. The Bluetooth connection is really fast. If you've ever tried to connect your Ev3 to Bluetooth or to Wi-Fi, it just takes a long time for it to find and connect to the network. This is much faster. Same thing is true of software. The Ev3 software is notoriously slow. This software is much faster. All right. So, wiring improvements is another one. I don't show this to you now, but the wires are thinner and more flexible compared to the old Ev3 wires, which were, you have varying sizes of them, but they're not very bendy and they're hard to adjust inside. Another thing that's a benefit is that you now have clips with the Spike Prime, and that means that you can connect a wire and position its direction very easily by wiring it along the way so it stays out of the way of whatever you're doing. Newer equipment. So this is something that's affecting my team in particular lately. We have had our Ev3 kits now for 4 or 5 years, and they're beginning to experience some wear and tear, and that's frustrating. So we've actually had major problems in tournaments lately where we had a brick start to fail very much towards the end of the season, right before our competition. And it just lost power. We had to return it. Now Lego's great about returning it, but that doesn't help us for our competitions. And we had actually didn't know that it was a problem, and we had been programming it to speed up or slow down based on the reactions that we got without knowing that it was actually failing us. And when we, at the end of the year, swapped with a new Ev3 brick that we also happen to have and ran our programs, all of a sudden they were running way faster. Something was broken in our Ev3 brick. Similarly, we've had problems with color sensors failing us. I think everybody has had the problems with the gyro sensor being flaky with the Ev3 unit. There's known bugs with the Ev3 gyro sensor. So one of the nice things about moving to Spike Prime is that you know you're getting new equipment, and so you have a little bit of difference in confidence and less likelihood of a failure if you move to a new kit. You can reorder the programs on the device. So this is actually a really fun one for those of you who've gone through that frustration of trying to put your programs in order for your competition with the new Spike Prime hub. That's really easy to reorder the programs that you have. and there's a one-to-one with what you have in the software. The next one I have is just here, Scratch programming versus Ev3 software. It's my personal opinion, and I think probably the opinion of lots of folks out there, but not everyone, that the Ev3 software and the LabVIEW software is not exactly the best environment for teaching or the easiest environment to program. There's lots of problems with it, and then you end up with very horizontal code or very long code visually because of the size of the blocks. And it can be very frustrating. When you move to Scratch, hey, Scratch is a language that lots and lots of the kids already know. They're already familiar with it. It makes sense. They're using it at school. They're using it for data code. And so it's an easy transition for them to move from Scratch programming on the web to Scratch programming for the Spike Prime. And then just in general, Scratch is really nice and easy to use. It's very efficient. Some wonderful positives there in the Scratch community. You also have the benefit of all the Scratch libraries out there and the Scratch how-tos that you can take advantage of. Now, there are some differences with Scratch for the web versus Scratch for Spike Prime, and there's not as much content out there yet for that. But if you've ever gone looking for Ev3 tutorials online, there are some out there, but there's nowhere near as much as there is in the Scratch community. And that brings me to one of the biggest things that I see is code simplification inside of Scratch. You can write a program in Ev3 and you can write a program in Scratch, and the Scratch program will most of the time be much simpler, particularly with the use of variables. So with variables in Scratch, you can create them as globals, you can set them or modify them, and you don't have to constantly declare them like you do inside of the Ev3 software, where you're having to do a write and a set and constantly and use different blocks for both of them. This is much more efficient for use of variables. Global motor control is an interesting one. I'll show this in the code. So here, I'll zoom in for you so you can see. We're in Spike Prime, and I'm looking at the kind of the kickstart when the program starts here, and I have 4 blocks that are global motor control blocks. So first I'm saying, hey, my movement motors are my A and E motors. You can see when I click in here that I can see that my large motors are A and E, and I can define that at the beginning, and then later on I don't have to say use A and E to turn. It'll automatically use them because those are the ones that are set as the movement motors. I can set a high level movement speed at a global level. I can set the value of one motor rotation, so I know the circumference or diameter of my wheel. Circumference of my wheel. And then I can also define whether I want always to brake when I stop. And then later on, as I'm creating movement blocks, those values will be reused for each one of those. I don't have to define them individually or set them separately. And I can change them globally as well. So that's a real nice one. Alright, let's go back to our 10th thing. And this to me is the biggest one, at least for us in our experience, and that is that the new gyro in the Spike Prime kit is now a 6-axis gyro, 3-axis accelerometer, 3-axis gyroscope. It includes support for gestures, which is really interesting. But more than anything else, it's built into the brick, and we're moving away from the Ev3 gyro, which really has lots of problems. For those of you who have been at the table and had the team trying to make sure that your gyro is not drifting, and the frustrations of this, the fear of being at the table and what happens if it starts drifting in the middle of our program, there's nothing you can do about it to prevent it other than turning it on the table and making sure that it's not drifting ahead of time. But that doesn't mean that it's not just going to randomly drift in the middle of your program, and that's happened to us at competition. Happened to us quite a lot at competition. I think also certain gyros are worse than others. And there's also the issue of generations of gyros on the Ev3, where some of the earlier gyros are actually better than the later gyros. So that's a really big positive for Spike Prime, moving over there from Ev3. Alright, now let's talk about some of the reasons you might want to skip Spike Prime and just stick with Ev3 for FLL. I think many of you will. Let's just talk first about the display on the Spike Prime. I'll just switch over there so we can look at it. So you can see that this display is really not a serious display. It is a 5x5 matrix of on or off white dots. And while it's cute and I can do emojis, it is just not a useful tool. It is not a screen. It can't be written to easily. If I have to write out a word, I see it letter by letter, which makes it just exhaustingly slow to read out a variable or something. Very, very frustrating when you're trying to program. There's also very little feedback that it can give you on current states of the sensors, or any preferences or settings that you might have, or what state your application is in, because the screen is so limited. So I just don't understand what they were thinking here. It's not like you can't get an inexpensive LCD. There are smartphones with incredible screens that are $100, $200 and include all kinds of other tools, just like this one does, at a $300 price point. So what's going on with that decision? It feels like they were really aiming this at kids and trying to make it fun and appealing to a very, very young audience. But then my next issue, and we switch back real quick, is that LEGO can't seem to decide who the audience is. Is this for kids? It looks like it's for young kids. They've got the really nice colors. They've got the emoji on the screen. But then it's marketed to kids grades 6 through 8. So it's marketed to 10, 11, 12, 13-year-olds. And it looks like something that's for 6, 7, 8-year-olds. So make up your mind. Which one is it? Maybe it's for legal purposes that they've aimed it at a 6 to 8 demographic, 6 to 8 grade demographic, not 6 to 8 years old. But it's very confusing. Pick one. Which way are we going? I feel like this is a tool that can compete with the Ev3 as far as capability is concerned, but it's there's just a few decisions that they made. They're just like, why did you go this route? And for me, the screen is a really big miss. I'm not impressed. Yeah, it's cute, but that's about where it ends, unfortunately. I'd much rather have a real screen on this tool. That leads to the next one, which is very basic monitoring. Because we can't display much, there's very little monitoring we can do. We can't set preferences on the device. We can't really see our values unless we're connected to the software. So if I want to read the exact motor position, I would have to plug into a computer and read it on the computer. I can't see it on the device. And even if I display it through a variable and display, I can only see one character at a time, and that's very frustrating. There are some basic functions that you can do to test to make sure your sensors are working. There's a default program underneath the heart that you can use to make sure and see what's plugged into each port correctly. And that's nice, but it's not very full-featured. It's nowhere near as useful as what you can do on the Ev3 for sensing and testing your motors or running your motors, etc. Alright. So, while we're at it, there's very few controls on this device here. I'll switch the screen so we can look at the buttons. If you look at the Ev3, you can see this, and it's not too close to the camera. There's 1, 2, 3, 4, 5, 6 buttons that are available for you. And that's a lot of variation, and of those, 5 of those buttons can be used while you're in a program. Now if we look at the Spike Prime, the same is not true. There are 4 buttons on the interface. One is the Bluetooth button, the left, the right, and the center button. You can't use the sensor button when you're running any software because it closes out of the software. Similarly, I don't believe you can use the Bluetooth button in any of the programs either, because it will just disconnect the Bluetooth. Now, I'm not 100% sure about that. I actually played with that to see if there's any way you can affect it, but I haven't seen any capability yet. So just another way that we're kind of limited here. Alright, back to the presentation. There's no contextual help in the software. In fact, there's very little help at all, and even when you do find the help, it's not where you want it, and it's not very full-featured. So let's just show you that. So here I am back into the software, and you would think that you'd be able to right-click on here and see contextual help. What is this block? What can I do with it? Can you show me some examples? Can you show me the ways that I can use this tool? And it's not there. There's no other options for help at all in the interface. And although there is a help menu up here, all it does is check for updates, which just goes out and sees if there's anything available for you to download. So no help in the interface. There's nothing under Window, View, or File. Now, there actually is help in the software, but I actually have to close out of my program, go to Home, and then in this interface, you have to figure out that under this setting here, there's a help button down here. Once you're in here, you can navigate around and read. But realistically, this is one gigantic text file of all of the elements in here and all of the help. But there's no code examples. There's no images. I can't do a search here. It's very, very, very basic help. And it's, of course, as I mentioned before, not contextual at all. So that's something I would really like to see improved in a future version of the software. I'm at 1.1.1 right now with the software version. But Lego, if you're listening, that's something that the community really needs, especially as we try to learn this new software. All right. Next is the fact that you can use spike prime blocks with Ev3, and Ev3 Scratch is coming soon. So the benefits of being able to use any of the Ev3 bricks can be done on an Ev3, so there's no benefit there. Similarly, Ev3 is moving to Scratch, so really the only benefit of spike prime comes in the parts that are not usable with Ev3, like the hub and the sensors, things that are wired in and programmed into this operating system. So Ev3 Scratch is not quite there yet. It's coming soon. We don't know how full-featured it will be, but if you can take advantage of Ev3 Scratch, then maybe the spike prime move doesn't make as much sense. Oh, real quick before I move on from that, another thing about this is that if you do choose to use Ev3 and you want to take advantage of some of the spike prime blocks, you don't need to buy the full set for spike prime. You can just buy the expansion pack, which comes with a nice set of bricks as well as the large motors. You don't get the large motors when you buy the base kit. They only come in the expansion pack, and those are the ones you want. Here, this is the difference. This is the wheel that comes with the base kit, and this is the wheel that comes with the expansion pack. If you're doing this for FLL, you definitely want the big one. Not that those small ones aren't good. It's possible some teams are going to want to use the small one, but I think most teams are going to want to use these large wheels, which are really nice. And that's something you can get with just buying the expansion pack and using it with your Ev3. Alright, so coming back. Oh, did I remember to change the camera? Here, let me make sure I did. So making sure that you got to see that. So this is the small one, and this is the large one. Alright, back to the presentation. There's a faster color sensor on the Ev3, so it operates at 1 kHz instead of 100 Hz. It's 10 times faster. Now, I don't know that that's going to make any difference. I've seen pretty good performance from the color sensor on Spike Prime, and one of the best features about the color sensor on Spike Prime is it uses white light instead of red light, which is actually better for color sensing. So I don't know that that's necessarily a benefit, but it's interesting to know that with Spike Prime they didn't improve some of the mechanical capabilities of the mechanical and electronic capabilities of the device just because it was 5 years newer. Alright, another reason that you might want to use Ev3 is if you really like the Ev3 software, there are some benefits. There are limitations of Scratch. Scratch is really interesting, but it is made for kids and aimed at kids, and there are some things in it that do drive me nuts in particular. One of them is that all variables in Scratch are untyped, which means that if you have a variable, you can put a 5 or a string or a numeric in there, and there's nothing to stop you from doing that. Whereas in the Ev3 software, you did have typed variables, and you could say, hey, this is an integer, this is a number, this is a string, this is a Boolean. Boolean is just a true or a false. Actually, another limitations of Scratch is that there really don't exist variable true and false variable Booleans. You can't make a Boolean variable in Scratch. Let me just show you that real quick without wasting too much time. But if I go to my variables and I create a new variable, and let's just call it is finished. Say I have an is finished variable and I want to just set it to true to begin. I can pull this out here, but I can't. There's no way to set a true-false value in here other than to put a string in it. So let's just say I was trying to wait until something was finished, and then I was going to, let's see, let's grab an if statement. If I was going to say if is finished, then do this. I can't drag is finished, even though I wish it was a Boolean variable in here, because it's not Boolean, it's a standard variable, and there's no way to put a oval into a hexagon slot. It doesn't work unless I put it into an operation. So I could say, I can't even use this one because this doesn't fit into that either. I could do something like if is finished equals and false, and that's really just a string comparison, and then I could put that into my if statement. So it's very kind of tedious to do just a Boolean true or false, and there's no way of doing a variable with that. Now, if I'm wrong on that, if anybody knows how to do that in Scratch and I just haven't learned it yet, please comment below. I'd love to find out that that's not true. I'd love to see that as a feature, but that's something that the Scratch community doesn't include. Is that the end of the world? Absolutely not. But it's just, these are programming things that are more or less convenient, or good programming techniques to have to be careful with your programming. All right. The next one I have is that there are only 6 spike prime inputs. So on the side of the spike prime, you have 3 on one side and 3 on the other. On the Ev3, you have 4 sensors on one side and 4 motors on the other side. There's a total of 8. On spike prime, you only have a total of 6. Although they're a little different, the 6 spike prime inputs are completely interchangeable, so you could have 6 motors, you could have 6 sensors, or you could have any combination of those 2 up to 6. Another thing is that you get an extra one if you consider the gyro, because in the Ev3 you had to plug in the gyro, so it took up one of the slots. On spike prime, it's built into the unit, so technically you have 7 inputs if you think about it that way on the spike prime side, but still it's 1 less. And then if you're thinking about that for FLL, you need 2 large motors to drive your wheels. You usually need 1 or 2 motors to move your elements, especially 2 if you're trying to do more than one thing at a time. And then we particularly use 2 color sensors for a lot of tasks, aligning to a line, more efficient line follower. And so that doesn't leave us with any other inputs at that point. If we go with our standard configuration, we don't have the ability to use the ultrasonic sensor or to use the touch sensor because we don't have any spots left over. So hey, that would be great if we could see an expansion hub in the future that you could then plug more sensors into. That would be great to see. I don't know if that's coming, but that's a feature we'd love to see come out of LEGO. Definitely a downside of spike prime in giving that up. All right. Wiring is fixed length to the sensors, so we talked about that. Wiring is better and more flexible, but it's also at a fixed length, and that means that you can't swap a short one out for a long one, which you can in the Ev3 world. So it is on one side of a sensor, it is actually hardwired into the sensor. Let me show you that real quick. So underneath here, you can see that it goes straight into the sensor, and you can't take it out. So if your length of your sensor to your brick is more than that, too bad. You have to rebuild your robot. You can't use a larger one. Maybe we'll have extensions in the future. That's true for all of the sensors, all of the motors. You're stuck with the size that you have. And then this is my last one, no Scratch repository integration. For those of you who've used Scratch online, Scratch has this really great online repository that you can upload your files, you can compare and share, and you can store your files online and then have them under another account. There's currently no integration whatsoever into that in the version 1.1 of Spike Prime. I don't know if they have any plans to do something like that, but I think it would be wonderful to see, because the online Scratch community is really great. It's kind of like a GitHub for Scratch, and it would be great to have kids be able to keep their Scratch programs for Spike Prime in the cloud, share them, and collaborate on them, etc. All right, so that's all I have for my 10 reasons to move to Spike Prime, or 10 reasons to stick with Ev3 for FLL. Hopefully that was helpful for you. We'll be doing much more Spike Prime content in the future, so we hope you'll subscribe and like the video, and we'll see you soon.